any question of designing an experiment, the very first thing is we need to label the variables. So in O levels, we don't have to really specify the variables, but that would always be a good practice to identify independent, dependent, and control variable. So this is there for this fair comparison. Independent variable means the thing that we need to change, the variable that we change. And dependent variable is the variable that is changed in consequence, changes as in response or in consequence, or the variable that depends on the independent variable. So describe the method. You need to explain the entire procedure. Another key pointer is whenever you take readings, you make sure you repeat the readings and take the average for like pretty much all the values. Then we have the next thing. You need to show, or you need to make sure you keep a fair test. Like I've given plenty of examples. So for example, you need to show which surface cools down faster. For example, in order to have a fair comparison, both the surfaces must be having same initial temperature. And then you need to show how results will be processed. The very first thing is what is the quantity that we change in this experiment? That would be your independent variable. Now, why is mass of the trolley independent? Because we'll change mass of the trolley and we'll find out if the distance changes. So the distance, this horizontal distance will be changed in consequence. This one, horizontal distance, will be changed as a result of different mass. So that should be then dependent variable. One more thing, the constants or the control variable. Now what thing should be kept constant in order to have a fair comparison? The next heading that we have is now how do we take the readings? This is the most important thing. In the exam, it's totally your choice if you want to make the headings exactly the way I have made, or what you can do is you can write in as a single paragraph also. It's totally your choice. Personally, I would say it's always a good practice to make the heading so you would know what statement you are missing and what statement you have written. Okay, and then we do not change that angle. Set up the ramp at a fixed angle and mark the starting point on the ramp. So all the trolleys, or the same trolley with different masses, but every time it has to be released from the same starting point. So for example, I can mark the starting point on the ramp, let's say here, which means here. So which means every time I place the trolley, I'll always place the trolley at this start line. You see, in order to have a fair comparison, all the athletes, uh, they start the race with the same starting point. After this, we measure the mass of the empty trolley using, whenever you write in the procedure about taking a measurement, you need to tell the instrument that would be used to take the reading. So I'm going to measure the mass of the trolley in full form electronic balance. So we measure the mass using the electronic balance. Now, once we have measured the mass, now we release the truck or release the toy truck from the marked starting point without pushing it. We need to release it. Release means without pushing. And once it covers, it rolls down the slope and then it moves on horizontal surface. It covers the distance. We measure the horizontal distance from the end of the ramp till the point where the trolley stops. What do I mean by this? From the end of the ramp till the point where the trolley stops. So let's say the trolley stops here. So I measure the distance from here all the way where the trolley stops. Now, is anyone from you thinking, shall we measure the distance till the front of the trolley or till the back of the trolley? The answer is it does not make any difference. What we need to do is, if we measure till the end of the trolley, then we need to do exactly the same in all cases to make a fair comparison. So for all other cases, whenever we add the mass, we need to measure the distance till the end of the trolley for all readings. If we measure the mass till the start of the trolley, so we need to measure till the start of the trolley for all cases. But whatever method you choose, whatever way you decide to go with, it should be same for all the readings. Using tape measure or meter rule. Either way, we should be fine. Yeah, tell me what should be the next step now. We have done, okay, number one, should we take just a single reading for the distance? Or isn't it always a good idea to take a couple of readings and then take the average distance for the same trolley? And find average distance for the same mass of the trolley. So we are done with the empty trolley now. Now we have to change the mass of the trolley. But these are most common ones you can find in the physics lab. So add the known slotted mass to the truck, measure the new mass anyway. So I'm adding for example 100 grams, but I'll measure the entire mass once again and repeat all the steps yet again. And take the average distance. So technically, once you move to A levels also, we do it at least 6 times, at least 5 to 6 times. So we'll take 5-6 more readings for different masses for the average distance. For each mass, we take the average distance. So what we're doing is we change the new mass, we add some more mass, take 3 readings of distance, find the average. Then we add another mass, 200 grams, take 3 readings, find the average. We add another mass, 300 grams, take 3 readings, find the average. Number 8. Okay, so the next thing is, once you have done all the readings, what you can do is you can make a table, and with the table you can plot a graph. Now, what exactly do we see? We don't need to answer that. For example, the conclusion, by the way, could be if we get a straight line, it means the more the mass, the more the distance. But we don't need to answer this thing. What kind of shape are we expecting? We don't know. We don't care. We simply write this one is a common pointer you can write for all the practicals that draw a graph and to form a conclusion. So the table that needs to be included should be containing the following things. Yeah, so what is the first column heading? What was the quantity that we were changing throughout the experiment? So the first column heading would be mass slash, what is the unit of mass? Grams. Okay, it's just a small experiment. It's not going to be in kilograms, so grams should be enough. If you want to write in kilograms, absolutely fine. Okay, then D1. D1 is the first time you measured the distance of that specific mass in centimeters. D2 is the distance in the second attempt. D3 is the distance in the third attempt. And what is the last one? D average. Very good. Okay, so you don't need to fill the table. And by the way, you could have added one more, what should I say? Yeah, column with serial number 1 2 3 4. Okay, but you're not supposed to fill the table. You just need to show the column headings. What do we plot on x-axis? What did we plot on the x-axis? Take a look. Mass. So this thing went on the x-axis, and the average diameter, because that was dependent on mass, it was the dependent variable, that was plotted on y-axis. Because you're not supposed to write these values, you're not supposed to fill the table, but just for explanation I'm writing certain values. For example, the mass of the trolley without any mass in it the very first time was 100 grams. Okay, I put it on the electronic balance, it gave me 100 grams. Let's say the first time the distance covered was 30.4 centimeters. The next time it was 31.4 centimeters. The next time it was 32. I'm just writing this way so it'll be easy to find the average. 32.4. What's the average? 31.4. And now you bring the new mass, you add in the trolley, which was already 100 grams, you add 100 gram of slotted mass. What's the total mass now? 200. Now what is the new distance? For example, let's say 40.8, then 42.8, then 44.8. What is the average? So this is how we fill the table in A levels. In O levels, you're not supposed to fill the table. You just need to leave the table as it is. You need draw the column headings, that's it. Exactly, for the personal safety. Yes, for the personal safety, and also for the safety of personal safety also includes the safety of the apparatus around you, the safety of, for example, the shelves, the safety of everything. So keep for example, I can say, uh, we need to ensure the ramp is stable enough and the blocks do not fall on our feet. So we need to ensure the blocks are placed tightly, they are secured tightly, or when the truck is rolling down the ramp, we keep our fingers clear of the moving truck. So safety precaution, how do we take the reading, how we form the conclusion, is explained by bullet number 8. How do we form the conclusion? Procedure explained in bullet 1 to 7. Dependent and independent variables explained over here. The trolley stops here. Then I can measure the distance till this point. Okay, everything that I'm doing right now, this is just an extra thing. If you get enough time, you should do that. Otherwise, no. Only if you get enough time, then you should be doing all of that.